Alrighty then. This is division using scientific notation, lesson 3 of 6. I apologize for my tattered sheet here. It has seen a lot of usage. Alright, from last time I brought up the point of 4 to the 4th divided by 4 to the 7th. And I said that we have a hunch that when you have the like base, what you can actually do, when there's division involved, on a like base you can take the power of the numerator up here, 4 to the 4th, and what you can do is subtract the 7, so it becomes 4 to the 4 minus 7th power. There it is right there. That becomes 4 to the negative 3, which in mathematical terms is 1 over 4 to the 3rd. Trust me, that's the way it works. And you can actually test this. It becomes 1 over 4 times 4 times 4, or 1 over 64, which is 0.015625. And go ahead, play with it, test it, use your calculator, computer, phone, whatever you use. Abacus, I don't care. That will come out to 0.015625. It does check. So this thing from last time is true. Excuse me. When you have like base, you can, and you're dividing, you can simply take the power of the denominator, the 7 here, and subtract it from the power of the numerator. Alrighty then. From last time also, we talked about what is 5 squared divided by 5 squared. Well, we know that's obviously 25 over 25, or 1. Fine. But from this rule we're developing here, that also equals 5 raised to the power of 2 minus 2. And that's 5 to the 0. Oh boy. That's actually true. Excuse me again, I've got allergies here. In general, any number raised to the 0 power does equal 1. I know that's counterintuitive, but you can check it anytime you want. You can do it with 5, you can do it with 4, you can do it with whatever. And you will always get that. Once again, turn to your calculator and check it out. You'll notice there are a lot of stars right here at this stage. I say 10 to the 0 equals 1. We're going to be using this a lot. So you want to really get to the point where you really believe this in your heart or soul, that when you take 10 and raise it to the 0 power, you get 1. Take 10, raise it to the 4th power, divide it by 10 to the 4th. You will get 1. And if you subtract the power of the denominator from the power of the numerator, you will get, I hope I got that right, you will get 10 to the 0. So 10 to the 0 does equal 1. By the way, forgive me if I'm getting numerator and denominator mixed up here. There are 6 lessons, and I've put hours into this, and my eyes are starting to go cross-eyed. So if I'm getting things mixed up, you get the idea. Just look at, I'm saying 4 raised to the 4 minus 7th power equals 4 to the negative 3. So there you go. You get the idea. I kind of squeeze this in here, but if you take pi and raise it to the 101st and divide it by pi raised to the 101st, you still get pi to the 0, which equals 1. And go ahead and check it on your calculator. It really works. Alrighty then. This is where we get interesting. Now is the time to reflect on the nature of numbers in scientific notation format. What are we talking about? We're talking about a digit, a decimal point, blah 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 numbers, and then multiplied by power 10 raised to a certain power. This is going to be critical, because starting in lesson 4, 5, and 6, but especially 4 and 5, you're going to start seeing a special type of division that will automatically create scientific notation for you. It's really a super keynote type of division trick. So just be sure you're really comfortable with all this stuff. I guess today's lesson really is 10 raised to the 0 equals 1, and for that matter, any number raised to the 0 equals 1. And you want to keep this in mind, how you handle the powers when you're doing division, and also focus on scientific notation when we're talking about a single digit, a decimal point, followed by some numbers, multiplied by 10 raised to some power. So there, that will give you something to mull over. But I hope I've gotten this all right. I apologize if I've tripped up anywhere again. My voice is not doing well, but there you go. So that's lesson 3. We'll see you next time.